Hi, welcome to this third video in our series on memory management in SQL Server. In today's video, we're going to be talking about the configuration of the min and max memory setting in Microsoft SQL Server. There is a lot to discuss in this particular property feature, so this video is going to break it down into two separate parts. First, we're going to talk about what is the minimum and maximum memory setting. Then we're going to talk about what happens when you get it wrong. The follow-up video will contain details about what is considered controllable by the minimum and maximum memory setting. Obviously, those who are senior folk would know that not every memory is considered as part of the purview of min and max memory setting, and we'll go ahead and get into details about what is considered part of it and what isn't, and how that impacts your memory capacity planning and sizing. Now, the first thing you want to understand is that this property is basically two things. It's got the minimum memory and the maximum memory. Often when we talk about memory, I see a lot of people discussing in depth about the maximum memory without really discussing too much about what minimum memory is about. But personally, what I've seen from experience is that the minimum memory plays a very important role in ensuring consistent performance for SQL Server. We'll talk about that in more detail as we proceed with this particular video. So let's get started with how do you configure memory in Microsoft SQL Server. The first one is obviously you can use sp-configure, and the second one is through Management Studio. You can right click the server properties, and within the server properties you will be able to see the option for memory, and inside memory you have the option for minimum and maximum memory. It's fairly straightforward. There's really not much going on over there as far as the settings are concerned. It's basically just two values. Typically what you'll find in the default is that the minimum memory is set to 0 and the maximum memory is set to the upper limit of the int data type. That's 2 billion odd something. Now let's talk about minimum memory. Minimum memory is the bare minimum that SQL Server will keep a hold on even under external memory pressure. Now, to understand this, you need to first keep in mind that when SQL Server starts up, it's not assured any amount of memory. It's basically just set to 0. And what that means is that as you start loading data, there is a possibility that some of that data is stored in the RAM because you have memory available. But as soon as the operating system goes back to SQL Server and says, I need some memory, SQL Server is obliged to release that memory back to the operating system. And therefore, external applications or external processes such as the operating system can exert pressure on SQL Server and cause SQL Server to relinquish the memory allocated to it. You can imagine why this is bad for us, because from a SQL Server standpoint, the whole reason why we use memory is to reduce the impact of bad or poor I/O characteristics. Like I mentioned in the first video, I/O is much slower than memory, and that's why we prefer to load as much of the data as possible in the RAM. If we don't have a consistent or bare minimum amount of RAM available to us, then our I/O performance will obviously suffer. So we might end up having physical I/O activity happening to the database, and therefore some queries might perform very well in this instant and then suffer severe performance issues the next instant simply because the data doesn't exist in the RAM. This can also happen with execution plans and a number of other things, because pretty much every operation in SQL Server needs some amount of RAM, some amount of memory. And we are basically allowing SQL Server to set a limit saying that I'm going to use a certain amount or X amount of RAM always, regardless of what the operating system tells me. And you need to set that value rather than leave it at the default. If you're a good DBA, you need to have one value for minimum memory setting. 0 is not really practical. We'll talk about why that is in a few minutes. Now, the first thing is to understand how this whole thing works. So I'm going to use a bit of a weird example here. So let's assume that you're sitting inside a subway or in a train and there's a seat. That seat is basically your RAM. And you're a data page. You've just gone and sat in the RAM over there. You're finally doing what you're supposed to, right? You're going from A to B. You need a seat. You're sitting over there. Everything is good. Now, what happens is that you're basically performing the query execution at this point and everything's nice. At some point, let's say a kid or an elderly person or someone comes up to you, and obviously what happens is that you have a long journey ahead of you and you need the seat. But unfortunately, what's happening is the people around you are staring at you and you feel kind of guilty, you feel kind of pressured into giving up your seat. And that way what happens is that the external pressure caused by processes outside of your SQL Server, who don't really know what SQL Server is doing, is forcing SQL Server to relinquish its hold on the memory so that some other data page can sit or some other information can reside or use that memory. Then you can see why this is bad for performance. This is basically what's happening when you don't configure minimum memory. There is no guaranteed minimum amount of memory for SQL Server, and therefore SQL Server always relinquishes its control over the RAM whenever the operating system insists to release it. So there is no guarantee that SQL Server will always have a certain amount of RAM available to it. Now, the other option is when you go ahead and look at it in the viewpoint of reserved seats. So, say for example, you go to a train, you have a metro, and there's a bogie or there's like a set of seats reserved only for ladies, right? So let's assume now you dress up as a lady and you go sit on that seat. Now again, you're going on a long journey, everybody's doing the thing, and a baby or a child or someone walks up and there's no seat available. Now in this case, what happens is that the other passengers are not really going to stare at you, because before they start staring at the lady to relinquish the seat, they're probably going to look for a gentleman to release his seat. And therefore, what's happening in this case is that because SQL Server has now got a reserved amount of memory allocated to it, the operating system does not insist to SQL Server to relinquish that RAM. In fact, the operating system doesn't even know that SQL Server's allocated that much amount of RAM to begin with. And in these cases, what's happening basically is that because there is a reserved quota of seats available for, or reserved quota of RAM available for SQL Server, which SQL Server insists it will not release, the operating system, even under severe memory pressure, will not be able to degrade the SQL Server performance. It'll just find other places to allocate that RAM from. And this is the whole concept of dynamic memory management, because essentially in dynamic memory management, what's happening is that the operating system and SQL Server are communicating with each other and trying to find a balance where both of them are able to get their job done without encroaching or degrading each other's performance too much. And in order to do that, for SQL Server to hold its ground against the operating system, it is important for you to grant or allocate a certain amount of minimum memory. I typically use 50% because there is a reason that I think that 50% would ensure at least some level of consistency as far as my query execution is concerned. Obviously, you might want to do a trial and error depending on the workload and other things like that. But typically what I find is that 50% right off the top in a very basic calculation works well for the majority of scenarios that I work with. So the other thing that, like I mentioned before, is that now you're dressed up as a lady and you're sitting in your seat, and if a baby walks around, the people don't stare at you because they expect someone else to release their seat, because you've got a reserved seat, correct? And that's kind of the bottom line here. SQL Server, by getting that minimum memory, is ensured or guaranteed a certain allocation of RAM. Now, the key thing to keep in mind here is that the minimum memory allocation is something that is only assured to you if you can guarantee you have enough data to reach that limit. A simple example would be in a train, they don't directly just go ahead and allocate 50% of the seats to women just because 50% of the population is women and 50% is men. They look at how many people consistently travel in the train and they do the bifurcation based on that. So you might have only maybe 20% of the general population in the train consisting of women, and that's why then you only reserve 20% of the memory in the system, or 20% of the seats in the train. So the first thing is you need to be able to guarantee a certain minimum amount of data that you will consume before you can set the minimum memory. If you don't set that, then what's happening basically is that you never reach that threshold, and because you don't reach that threshold, you're not really guaranteed to have that memory. The idea being that, let's say I have a system with 8 GB of RAM and I've set 4 GB as the minimum memory. I need to be able to load 4 GB of data into the RAM before I reach that threshold at which SQL Server says that I've got 4 GB, I'm not letting it go. If I've just loaded 3 gigabytes of RAM, 3 gigabytes of data, then I've not reached the threshold where SQL Server says, okay, I know that I've got 3 gigabytes, so I'm going to latch on to 3 gigabytes. I'm not going to give it to anybody. SQL Server is still waiting for 4. So until it reaches 4, SQL Server will say, well, looks like I'm not heavily loaded. Looks like I've got plenty of RAM. I probably don't need this. So it'll go ahead and release that memory back to the operating system. So if you want that consistent behavior, you'll always want to set somewhere around 40 to 50%, just so that you know that at least half of the data that you fetched previously is always sitting in the RAM, right? And that's what this min memory configuration is about, right? Now, we'll talk about what it looks like in a minute. Yeah. Okay. Now, when it comes to virtual machines, you need to keep in mind it's a special scenario, because when it comes to minimum memory or any memory setting for that matter, the instances, let's say you have 2 installations of SQL Server on the same hardware, or let's say you have multiple virtual machines, they don't know how many other instances are running on the system. They're fairly isolated from each other. And because they don't really understand how much memory is allocated to another system, and they don't negotiate with each other. The only negotiation that happens is between the instance of SQL Server and the operating system. If there are other instances of SQL Server or other operating systems, like in a virtual machine, they don't negotiate with each other. And because of that, you need to be careful when you configure this. Say, for example, I've got 20 gigabytes of RAM and I want to host two virtual machines on the same hardware. A simple arithmetic would tell you that each VM should get 10 gigabytes of RAM, but that's not really correct, because the host operating system would need 2 gigabytes of its own, and then the guest operating systems would need an additional 2 gigabytes of their own. So right off the bat, 6 gigabytes is off the table, leaving you with only 14 gigabytes of memory. Now, in that 14 gigabytes, you need to bifurcate it by 2, because you got 2 instances of SQL Server running. So you're left with 7 gigabytes of memory per instance of SQL Server. And to ensure consistent performance, I would then break up that 7 gigabytes as 3.5 gigabytes of minimum memory for instance 1, 3.5 gigabytes of minimum memory for the second instance, and the additional buffer of 3.5 on each instance to give them that volume or that ability to grow and shrink their work set as needed. So that's a very right off the top of my head, a basic calculation that I would do. There are other features as well that use SQL Server, so we'll talk about in-memory OLTP and stuff like that later on. But you can see how it's not always as straightforward as just go ahead, put it on the defaults, or just take the number and divide it by 20. Often what I've seen is people go ahead and use some kind of percentage. They usually say something like 80% or of the memory should be allocated to SQL Server. That also I don't really think works, because on a 1 terabyte system, 80% is still a lot of unused memory. So this is not really something you want to calculate with percentages. It might work for smaller systems, but nowadays we see systems with 1 terabyte very easily. So a percentage based calculation doesn't usually work. Typically what I would do is I would allocate anywhere between 6 to 8 GB for the operating system, giving me plenty of room to grow later on if I need to. I can even host a few other applications on the same machine, because there are peak times and non-peak times as well. And then whatever is left, I then break it down into how much memory do I need for in-memory OLTP, how many instances do I have. All that comes into play. So the important thing to keep in mind here is that you need to go ahead and ensure some minimum memory just to be consistent. Next, let's talk about maximum memory. Now, the maximum memory is basically the threshold or the upper limit that SQL Server can use. So essentially what it means is that even though your system may have maybe 64 gigabytes of RAM, SQL Server is committing that it will not consume more than, say, 32 gigabytes if that's what you've set as the maximum memory value. Now, the thing to keep in mind here is that the maximum memory value is actually more like a speed limiter on a bus. This bus could possibly go up to 120 kilometers per hour, but that doesn't mean that you will drive it at 120 kilometers. So the max memory is more of a setting that basically says that even though the bus can potentially go up till there, I want it to restrict itself to not more than, say, 80 kilometers per hour. Correct. And it's basically, it's not a very hard limit. Usually there is some variance in that upper limit of a few hundred megabytes. It has to do with column store indexes, which we'll talk about later. But the idea here is that the max memory setting is basically the agreement that SQL Server has with the operating system, saying that I will not encroach into the operating system beyond what my maximum memory limit is. Similarly, the minimum memory is basically an agreement between Windows and the SQL Server, where Windows is committing that I will not commit you or force you to release the 4 gigabytes or whatever minimum threshold is available to you as part of your minimum memory setting. And you can see how these two settings complement each other, both protecting the operating system as well as SQL Server from unnecessarily overcommitting or releasing memory unnecessarily. Now, before we can start talking about maximum memory, there are two performance counters we need to be aware of. The first one being total memory and the second one being target memory. So let's go ahead and have a look at that. As you can see here, I've got the two counters already available. So you'll have my target memory set at 512. This is 5 gigabytes, and then you have the total server memory, which is running at about 1 gigabyte right now. Right. So the thing is, when you're working with target server memory and total server memory, you need to keep in mind that the target server memory is basically tightly correlated with the max memory setting. And what that means is that as you change the maximum memory of SQL Server, it'll directly have an impact on what you see as part of the target server memory. So let's have a quick look at that. I'm just going to go ahead and put the target server memory. It's running at 5 gigabytes, as you can see here. Let's set it at 5 gigabytes. Let me change that to 3 gigabytes over here. And as soon as I do that, you'll see in a matter of seconds, the performance counter is going to dip from 5 gigabytes right down to about 3, as you can see here. And what this means is that there is a correlation between the maximum memory setting and the target server memory. And typically, when you look at online documentation, it basically says that the target memory and the total max memory is pretty much the same thing, but it's not. So let me show a demonstration of that really quick. I'm going to go ahead and change this to about, let's say 9 gigabytes now. Now, thing is, I've actually got 10 gigabytes of memory available. So you can see here that under my memory available under the operating system, you'll see that I've got 10 gigabytes of memory available. So if I set the maximum memory to 9 gigabytes, that means that my target memory can go all the way up to 9 gigabytes. But what you'll notice is that it's flatlined right at around 6.5 gigabytes, as you can see there. So the target server memory, while technically follows the maximum memory when memory is available, it doesn't necessarily always have to be the case. As you can see in this case, the maximum memory setting that I have available allows me to potentially go all the way up to 9 gigabytes. But at the same time, SQL Server, as I mentioned before, negotiates with the operating system on what would be considered a fair upper limit. And so in this case, SQL Server has decided that while it can potentially go up to 9 gigabytes, it really only needs about 6.3 gigabytes. And that's kind of the limit that it's set voluntarily on its side. Potentially, there is a scenario where later on other processes might disconnect or might be terminated and more memory frees up. And there is a chance that the target memory will ramp up to 9 gigabytes. But as it stands right now, the target memory is stuck at 6.3. And that just means that setting maximum memory doesn't necessarily always mean you will reach that limit. There might be a lot of external factors that prevent you from reaching it. So it's important to do a baseline and understand what is your target memory, ideally after a typical workload, and then understand whether your maximum memory aligns with that value. So as you can see in this particular case right now, my total server memory, as you can see, is about 1.1 gigabyte, and the target server memory is 6.3, which means that I've got plenty of room to grow. There's nothing running on the system. It's not ramping up. That's a typical workload hasn't actually been executed on the system as of right now. So I'm going to go ahead and now reduce the maximum memory to say 4 gigabytes. Oops. So let's go ahead and make that 4. And you'll see that as soon as I change it to 4, the memory is going to dip again. You'll see that now the target server memory, which is, like I mentioned earlier, it correlates clearly with the maximum memory, but it's not a hard limit. It doesn't always have to correlate exactly with the max memory. Sometimes your max memory might be a higher value, and it's just not possible for SQL Server to allocate that because of the agreement that it has with the operating system. So it adjusts for a reasonably close value, which is what you'll see on the target server memory. Now, in this particular scenario, I've reduced the size of my target server memory to about 4 gigabytes. And my queries, there's really nothing running on the system at this moment. So typically when you look at the documentation, Microsoft SQL Server MSDN, what you'll find is that the recommendation that they say is the total server memory is consistently below the target server memory. You potentially have a memory pressure issue, and that's technically correct, but in this case it's not, because I've not ramped up. This system is sitting idle, it's not doing anything, which is why it never really decided to go all the way to that limit. Now I need to make sure my SQL Server is running under a typical workload, and under that scenario I need to see, even when a typical workload is being executed, does this memory remain at 1 gigabyte, or does it try to utilize the amount of memory available to it, which is in this case potentially 4 gigabytes. So if I'm running a query and it continues to remain at 1 gigabyte, there's probably some external factor that's kind of like suppressing the value and preventing it from exceeding beyond 1 gigabyte. But if it's able to ramp up to 4 gigabytes, then potentially what it means is that SQL Server has decided that I need more memory, there is more memory available, I'm going to go ahead and grab onto it. So what I'm going to do now is I'm going to run this query here. You can see that I was getting out of some memory exception before, insufficient memory. But that's because I changed the value to like 1 gigabyte, and there's definitely not enough RAM to do the job. But as you can see now, it's executing, right? And as soon as it executes, what you'll see here is that immediately SQL Server has decided that I can potentially go all the way up to 4 gigabytes. I was roughly about 1 gigabyte before, and now I'm going to go ahead and ramp up until I reach a limit where I think that I've got enough memory that I need. or I have reached the limit that SQL Server has decided that I'm not allowed to cross. So in this case, you can see that it's flatlined roughly about 3.8. So what's happening here is that SQL Server has allowed me to ramp up to 3.8, and at that level, I've decided that I don't really need any more memory, and so I'm stuck over there. I'm kind of like stopping, and I'm saying that, yeah, okay, I've got the memory I need, so I'm good to go. In this case, we're not really facing a memory pressure issue because I have a potential limit of up to 4 gigabytes. I just don't have enough work to reach there. And that's why we're stuck at this level. I could also just go ahead, take this query, and then, probably just execute it in another session. And when I do that, you'll see again, the total server memory is now increasing a little bit as it tries to allocate more memory for the second query. And this is basically the behavior that we typically expect. The intention here being that there is a hard limit set by the target memory, which is correlated with the maximum memory, and the total memory is what SQL Server decides ideally it would like to have. And whenever possible, it will like to have as much memory as possible just so it can get the job done faster. But that limit is always constrained by whatever value you have under the target server memory. So in this case, as you can see, running the second query has not really caused it to be too high. You can see it's about 3.97 MB. Correct. So again, at this point, what we're basically seeing is that the total server memory is always going to be a little bit less than the target server memory, or almost exactly the same as the target server memory. Usually you'll find them pretty much aligned. And that just means that under a typical workload, SQL Server is using as much memory as it can. And that's a good thing because then it means that it's not having memory pressure. It's trying to get the job done as soon as possible. Ideally, these two values should be as close to each other as possible because that just means that I have a certain requirement of memory and I'm getting that. So it's always good. A little bit less is also fine, but it shouldn't be too high or too low. That's kind of the sweet spot if you want to think about it that way. So as you can see here, this query is executed. I'm just going to go ahead and make it a little bit larger so that we have a nice overlap between the two sessions or the memory allocation for the two. So you can see that as I increase the volume of data that needs to be inserted into the table, now the target server memory and the total server memory are fairly similar. They're kind of like very closely aligned because the total server memory is saying that I, SQL Server, would like to have about 4 gigabytes of RAM, and the target server memory says that, yeah, well, I have 4 gigabytes and I'm not allowed to let you use more than 4 gigabytes, so you can have access to all the 4 gigabytes that I have here, just not allowed to exceed that. So that's a good thing. So SQL Server basically is preventing the total server memory from running out of control and encroaching into the operating system memory by putting this hard limit of target server memory. So the idea here is that the target server memory is the maximum upper limit that you can reach, and the total server memory is what you would like to have in order to get the job done. And ideally, the both should be the same so that you're using as much RAM as possible. And that's what you're seeing here. So in this particular case, you'll see that the total server memory and the target server memory are pretty much the same, which means that any additional queries that I execute is just going to put more stress on the system because there's just not enough RAM available to get any more work done, right? So I could potentially now come here and say that, oh, you know what, we've got memory pressure or we've got some issue. I want to increase that to 5 GB. So my total server memory, my target server memory is now going to be 5 gigabytes. And you can see that as soon as the target server memory becomes 5 gigabytes, the total server memory is having that buffer. Correct. So in this case, what's happened is that this is not memory pressure. This is just me increasing the memory capacity of the machine. But SQL Server has decided to continue to use the 4 gigabytes it has because it's already been allocated. It's able to do the job. You'll see that it slowly ramps up over here. It keeps increasing a little bit, right? As more and more work is being executed, you'll see that the target and total server memory will try to follow each other. And that's a good thing. That's kind of what we expected to do. SQL Server should try and utilize as much memory as possible. So that's kind of the rough idea about what target and total server memory is. Now let's talk about the maximum memory setting. The maximum memory setting, like you saw here, is an upper limit. So potentially what you want to do is try and grant as much memory as possible to SQL Server, keeping aside memory for in-memory OLTP systems as well as the operating system as well. Now, in some cases, I've seen that the minimum memory and the maximum memory are set to the same value. That's a bad practice, simply because when you set minimum and maximum to the same value, potentially you never reach the minimum, so you never really have a dedicated reserved amount of space, as we talked about earlier in this video. Assuming that you did actually run a very heavy query and you've reached that minimum, then you don't really give SQL Server and the operating system any room to negotiate, because SQL Server is now restricted to that hard limit that the minimum memory has set, which also happens to be the maximum memory. And essentially at this point, what you're saying is SQL Server is always guaranteed to have that much amount of memory. And that doesn't leave much room for SQL Server to dynamically adjust the memory and cooperate with the operating system, which means that potentially you might end up in a situation where the operating system gets into memory pressure and shuts down. And as a result, naturally, SQL Server will shut down as well. At this point, I think we've made it pretty clear that you need to be careful about these memory settings. There's more to follow. So at this point, I'm going to stop the video, and I'm going to talk a little bit more about what constitutes the contents of memory when we set min memory and maximum memory. So that would be in thread stacks and other assemblies that you might be using, but we're going to have a discussion about that in the next video. This turned out to be a little bit longer than my normal videos because I was trying to cover all these concepts in one nice big block. I hope you've understood the difference between min memory, max memory, how they work, the impact that they can have on the memory utilization of the SQL Server instance, and at the same time, how you would correlate that with performance counters to identify whether the performance counter is indicating to you that there is some kind of memory pressure or not. You'll also find other performance counters such as buffer cache hit ratio, page life expectancy, lazy writes per second. All these have some correlation with memory pressure, but you need to be careful because if you don't understand the internals and how each of these counters behave, you might go down the wrong track. So we'll talk about that in future videos as well. I hope you've enjoyed this video, and thank you for watching. Stay tuned for the next one where we talk about the contents of memory that will be stored as part of your buffer pool. Thank you for watching.